Alright, so I'm going to continue today with integration. I'm not going to do anything new, but I'm going to go back over all the stuff we've already covered. The homework through this weekend is going to be more practice problems on integration with logarithms and exponential functions. The objective's still the same. We're going to integrate logarithmic and exponential functions using u substitution. So I'm going to start off with this example here. So I'm integrating from 0 to okay, this should be from 0 to pi 6, I believe. I'm integrating from 0 to pi 6 of 5 sine 2x dx over cosine 2x. First thing I'm going to do is I'm going to make a substitution. Now, whatever I set for u when I derive it, I'm going to end up with the derivative on top since I have to have a u prime. So if I say u is equal to the cosine of 2x, that's the bottom part of this fraction. When I derive cosine of 2x, I would get negative sine 2x times 2 dx, or negative 2 sine 2x dx. That is the right function that I have on top, sine 2x dx. So I can make that substitution. However, I don't have a negative 2 in front. I've got this 5 instead. So I'm going to change some things around. In order to get the negative 2 that I need, I'll multiply by negative 2 and divide by negative 2. That way I don't change the original problem. So now I have a negative 2 dx that I can substitute for. I'm also going to change my bounds. My lower bound was 0. If I plug in u at 0, I'll get the cosine of 2x is u, so that's the cosine of 2 times 0. The cosine at 0 is 1. So my new lower bound from 0 will become 1. Okay, my new upper bound was pi 6. If I plug in pi 6 into cosine of 2x, it'll be the cosine of 2 pi 6, which is the cosine of pi thirds, which is 1/2. So my new upper bound will become 1/2. Okay, if I rewrite this, so here's my negative 2 and then divide by negative 2 that I had last time. So that gives me a negative 2 dx that we can substitute for part of our u prime. I need a negative 2 dx and a sine 2x. So everything that I've circled, I can substitute for as u prime. Okay, then u is the cosine of 2x. Everything I'm underlining here is my u. That leaves me with 5 divided by negative 2 on the outside. Okay, so after I make my substitution, we've got this. Negative 5/2 times the integral from 1 to 1/2 of u prime over u. Okay, if I integrate u prime over u, I'll get the natural log of u. So this is negative 5/2 natural log of u from 1 to 1/2. So I'm going to plug in my upper bound. That's negative 5/2 natural log 1/2. Minus my lower bound, negative 5/2 natural log 1. The natural log of 1 is 0, so this is minus 0 times negative 5/2, or minus 0. So that leaves me with just negative 5/2 times ln of 1/2 as my final answer. Any questions on what we did here? Okay. So I'm going to try a couple more from scratch then. Can someone tell me what they think the u would be for number 1? So what could we substitute?
4x cubed minus 3.
Okay, I think that was Eileen. So 4x cubed minus 3. That means my u prime will be the derivative. So that's 12x squared dx. Okay, we don't have any bounds, so I don't need to substitute any bounds. I don't have a 12x squared though, I've got a 48x squared. So how could I break apart 48 so that I have a 12?
4 and 12.
4 and 12, perfect. So this is 4 times 12x squared dx over 4x cubed minus 3. Is the same thing as the integral of 4u prime over u. That 4 is a constant, so I can move it out. Okay, if I integrate u prime over u, I get the natural log of u. So this is 4 times the natural log of u plus c. And then u is 4x cubed minus 3. So this is 4 ln of 4x cubed minus 3 plus c. Okay, now I did put absolute value signs here. That's because a natural log has to be of a positive number when we're in our final answer. So I can't plug in a number that would make this the natural log of a negative number, since natural log of negative numbers don't exist. It is possible to have natural log of negative numbers in an intermediary step, as long as I had something like this: natural log of -4 minus natural log of -2. As an intermediary step, that's okay, because with my properties of logarithms, this is the natural log of -4 divided by -2, so I'm not actually taking the natural log of a negative number if I use my properties of logarithms to combine these. Before I actually take the natural log, this will become positive. That's okay. But as a final answer, I can't plug in a negative number into my natural log. I'm not going to count off if you don't write the absolute values, but once I release the keys, if I release the keys for the homework, if you see absolute value signs in your final answer with anything for natural log, that's why. Any questions on 1? Okay, going to 2. I think I'm going to jump down the line, so we'll just start calling on people. Let's see, I've got next as Sarah. So for number 2, what would my u be?
Can you hear?
I can hear. So you said u is 3? If I just sub for 3, u prime would be 0. And that wouldn't allow me to sub for the dx, so I need something else.
Cotangent minus 3x.
Okay, if u is cotangent -3x, then that means my u prime would be, if I derive cotangent, I get negative cosecant squared of -3x times -3 times dx. Okay, that does give me a dx that I need. And cosecant squared is what I have on top, cosecant squared -3x. So I can make that substitution. The -3 will cancel. So that leaves me with u prime is 3 cosecant squared -3x dx. If I substitute, this is the integral of negative u prime over u. So I still have that -1 on the outside. I'm going to pull that -1 out, and then I can integrate u prime over u directly. If I integrate u prime over u, I get natural log u. So this is negative natural log u plus c, and then I can sub for u. Negative natural log of the cotangent of -3x plus c. Any questions on 2? Okay. My u prime is always going to end up giving me a dx on the top of my fraction. If I tried to substitute for cosecant squared instead, or maybe the cosecant of 3x, since that's inside the squared part, the derivative of cosecant is negative cosecant cotangent, and that doesn't help me get rid of the cotangent negative 3x, which is on bottom. So I wouldn't be able to substitute for that part of x. So that would be my clue that I need to try something else. Down here is a little bit interesting. Any guesses on what my u could be? Okay, I still need to get a dx in the end. If I tried to set u equal to this x part, my u prime would be the dx that I want, but I would not substitute for this natural log of negative 5x, so I'd still have an x in the problem, so that doesn't work. So I'm going to try negative 2 plus ln of negative 5x, everything that's inside these parentheses. If I do, I'm going to rewrite that so it's a little bit nicer. Negative 2 plus the natural log of negative 5x. If I derive natural log negative 5x, I'll get 1 over negative 5x times negative 5 dx. Or dx over x. So that means the dx over x is all part of u prime. And this negative 2 plus ln negative 5x is part of u. Which works, because that means I will not have any x's left in the problem, which is our goal. Okay, so if I sub in, this will be the integral of u prime over u now, which is the natural log of u plus c, and then I can substitute for u. So this is the natural log of negative 2 plus ln negative 5x plus c. Okay, I'm going to keep going. For this one, if I set my u equal to the bottom part, when I derive I'll get 4e to the 4x, which is what I have on top, times dx. So my u should be e to the 4x minus 5. U prime is 4e to the 4x dx then, which is what I have on top. So this is again the integral of u prime over u, which is the natural log of u plus c, or the natural log of e to the 4x minus 5 plus c. Any questions on anything showing on the page? Okay. I've got 4 more. For this one, I'm going to set my u equal to the power. So this is 3x squared plus 5. That means my u prime will be 6x dx. Okay, that does give me the right power of x to substitute, so I won't have any x's left, but I don't have a 6, I've got a negative 30. Negative 30 is negative 5 times 6, so I could rewrite my original integral as negative 5 times 6x dx, which is my u prime, times e to the 3x squared plus 5, which is my u. So when I go to substitute, this will be negative 5 is a constant, I can pull that out, times the integral of e to the u times u prime. Okay, if I integrate e to the u prime, that'll get me back to e to the u. So this will be negative 5 e to the u plus c, or negative 5 e to the 3x squared plus 5 if I sub back in for x. Okay, same idea here. I've got a secant something, tangent something, and a secant something is the 2 parts that I could be substituting for. Since the derivative of secant is secant tangent, I'm going to try that route. So my u is going to be equal to this secant of 4x. And if I derive that, then I'll get the secant of 4x times the tangent of 4x times 4. And then derivative inside 4 dx. Okay, so 4 secant 4x tangent 4x is the right trig functions that I need for the secant of 4x tangent 4x here. Although I do need 4 and I have an 8 right now. 8 is 4 times 2, so my original function was 2 times the 4 secant 4x tangent 4x dx that I would need to substitute for u prime times e to the secant of 4x, which is my u. So if I resub for this would be 2 times the integral of e to the u prime again, which when I integrate e to the u prime, I get e to the u. So this is 2 times the e to the u plus c, or 2e to the secant of 4x plus c. Any questions on 5 or 6? Okay, last two. I've got options here. I could try to substitute for x. If I do, though, then my u prime would be dx, and I would still have a natural log of x up here, so that doesn't work. So the next thing I would try is probably to substitute for the power. So u is 2 plus the natural log of x. If I do that, then u prime would be 1 over x times dx, which would get rid of my x that I have on bottom and the dx I have on top, which means I would not have any x's left, which is what we want. So this is the integral of 5e to the u power, so that's 5e to the 2 plus ln x, times u prime, times 1 over x dx. Okay, is my substitution. That 5 is a constant, so I could pull it out. So this is 5 times the integral of e to the u prime, and then when I integrate e to the u prime, I get e to the u. So this is 5e to the u plus c. I can resub for u. 5e to the 2 plus ln x plus c. And the last one. I've got e to the x and a negative 2e to the x minus 5. So if I substitute for e to the x, my u prime would be e to the x dx, which is not the right power. I would not get rid of this here. So I'm going to try substituting for the entire power then. So u is e to the x minus 5. U prime would be e to the x dx, which would get rid of this e to the x and this dx and this power. So that gets rid of all of my e to the x's. Okay, so I'm going to resub for that. E to the x and dx is u prime, where e to the x minus 5 is my power. So that gives me the integral of this negative 2 is a constant. I'm going to pull that out. Negative 2 times u prime is e to the x dx. So I've gotten rid of that part. I've got the negative 2, I've got the e to the x, and I've got the dx. So I'm left with e to the u. And we're good. Okay, if I integrate e to the u prime, I get e to the u, so this is negative 2 times e to the u plus c, or negative 2 e to the x minus 5 power plus c. All right, any questions on any of the problems from today?
No.
Okay, I worked that out a little bit fast, but I'm going to go ahead and link this with all of the worked out solutions. The homework for today is pretty much the same as what we did here in the PowerPoint, but with different numbers. You'll have 16 problems instead of 8, and it's really just for fluidity. So if you think of math like a language, when you're learning a language, you've got some parts of your study that you'll do where you're just trying to get fluency. So it's easy stuff that you do to try and get used to a language. And then you've got harder stuff that's more challenging that you might study more intensely. So we've been doing the harder stuff that is new so far, and I want to go back and just kind of do a couple more practice problems for fluency, if that makes sense. Okay. And then we've also got the homework from Wednesday that I'm going to be taking next week as well. So that was the 2 word problems and the 16 problems from earlier. So So we'll keep all of these annotations and send that through WeChat. Oh, can't rename because I've got it open. Okay. All right. If you guys have other questions, please let me know. I am still going through to check for incompletes one by one. So if I don't think I've gotten to any of the pre-calculate actually, but once I get to you, you'll get a notice if you're missing any assignments, or a notice that says I've got all of your assignments up through this point. I've been told a little bit updated information. The quarter 3 is going to end officially yesterday for grades. So the grade for this homework assignment will count as our first grade for quarter 4. And your grades will go through Wednesday this week. Our grades for the teachers can be submitted through Wednesday of next week. They're going to take Thursday morning and start printing. So that does mean that I need any late assignments that you have, ideally by Tuesday, that way I've got Wednesday to grade it. So if I have everyone try to give me late assignments on Wednesday all at once, I might not have time to get through before they freeze for me. So I'll try to get those notices to you as soon as I can. I'm just going through the students as fast as I can. Okay, thank you very much for coming, and I hope you guys enjoy the weekend.